Welcome back, everybody. It's Damon, also known as Crazy Logics or Crazy Logics 007 on YouTube. Got this amp. We went ahead and did all the repairs there on the drive circuit. If you watched the previous videos, got all the FETs back in. Everything looks great with the square waves. We'll hook some power up later to do that. Right now we wanted it dead with power to replace some capacitors. I've got one here. It's definitely swollen. This one and this one that's slightly. These are off-brand. Look, here's the negative side of these electrolytic capacitors, and they happen to have a nice little notch here that tells us where the negative needs to go. So guess what? The capacitors came in. I've got the correct ones. I went ahead and got some Nichicons. I like putting in decent capacitors. We don't want this same crap happening again. We want this amp to last. So we've got those. I'm going to show you how I remove capacitors. Now, when you have these big caps, they're going to be, here it is, 1, 2, 3, 4, 5, 6, 7, 8, all the legs. They've actually got these bent over. There's another type of capacitor that's got short legs that are called snap ends, and they're going to be on this. But you notice there's this a big ground plane. And then these smaller areas, one here, 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 and here, those are going to be easier. So you kind of really need a bigger soldering iron. I've got my big Unger here. It does a really good job of dropping out FETs and doing this stuff. But not everybody's got a big iron. You can get bigger irons at the hobby stores for soldering wires on the battery packs and electronic speed controls for RC cars and stuff. You can get a pretty cheap one. I have a Hobbyco one around here. I'm not sure. May have it. Yeah, I don't see it. I thought I may have had it there in my little junk pile. But it's got some thermal mass to it. It's better than a little, 30-watt pencil cheapo irons and stuff, and can help you do that. So I'm going to do it with this, but I'm also going to do it with my Heiko FX888D with a small tip. I'll show you can do it. You just got to work at it a little bit and know a little bit about what you're doing. So number one secret first is we're going to add some leaded solder to everything. And so we're going to do the easy little ones first. I'm going to do with the Heiko one of the big ones right in the middle of this ground plane to show it can be done. But we're going to go ahead and hit that. Hit this one with a little leaded solder. Hit this one. And this one. All right, so let's take the little Heiko out, get a little solder on it so we get good conductivity. Hold that sucker in there, and it's going to take a lot of it, but you're going to be able to flow that in there, and Shazam, it did it. It just takes a little while longer to do it. You want to get it right in there on that leg, because that's where you want to get that fresh solder to lower that melting temperature in that area. You're not having to melt the whole thing. Now, a quality soldering iron like this Heiko heats up quicker, does have a little better thermal mass. My Unger has big thermal mass and a big heater. It's not that it has some great computer control. It's a plug in just straight to the outlet. Doesn't have a nice temperature controller or anything. So you can solder suck this, whatever. These solder bulbs, this is my old one, and it still works. The rubber is all crackly looking, but it still works. I got a new one. I like having these little suckers around as backup, and they're great for when you need to do a whole bunch of bulk. Just have you a little something to poke down in there to clear it out when it gets goobed up a little. But it's really, really good for when you need to do a whole bunch of mass desoldering. So we're just going to go through and let's see, I said I was doing all these little ones. with the big iron. I'm doing the others with the smaller. Now, I do somewhere have a little bitty old 30-watt pencil. I don't know where it's at now, since I've got my Heiko at Christmas time. I have just been in love with it, and it is better than some of the cheapo pencil irons and stuff. But we're going to go ahead, and you're going to get here and get this leg, get it desoldered, and we want to straighten it up. Now remember, anything metal you're using is going to act as a heat sink. Sometimes once you get it, you can actually use the soldering iron. We want to get them straight up and down so that we can be removing this stuff. And we're going to have to suck a little more solder once we've got it up, but sometimes to get adequate heat flow, you have to add a little extra solder so you can. Well, this one's stuck in there. There we go. Once you get it up, so let's go back to the Heiko and let's see if it'll get these cleaned up. A little solder on here to improve excuse me, improve the heat flow. Okay, that one we got plugged up. We need to be able to do it, and that's why I like having two laying around. Go ahead and reach up underneath here with the soldering iron, get it to bend straight up, go around that leg, get a little more out. I'm just going to work these things, work this around there. We got one last one, but man, you can do it with your soldering iron. Better quality soldering iron is obviously helpful. Never hurts to have quality stuff, but that will get the job done. Now, a lot of times, these will have goo on them. Oh, we just bent some of those legs back down. These will have some goo on them, gluing them together, gooing them down to the board, and you need to work that off. Now, when I glue them back down, I use E6000. That's the industrial version of shoe goo. Shoe goo works just as good, helps for vibration on all things, on caps, transformers, everything to help bond them down. Shoe goo's better than silicone. The E6000 is better than silicone. The whole reason being is if you've ever put silicone down on something and then went to peel it off, it will leave residue. It's hard to peel off. It tears components off and everything. This E6000, super good adhesive and everything, but it peels out clean. When you work to get it off, you don't get that residue. You know, it doesn't adhere so hard sometimes to the components that it rips them off or something like that. And it's just the right amount of adhesion and vibration proof and all that stuff. It just hits that sweet spot without being a mess like silicone can be. So we're going to set this up. I'm going to get a little stick of wood, So I can get under here. Oh, this is the one that's all plugged up. There we go. And we'll try and make sure we get as much away from the leads as possible. We're going to give it a little tug down. There we go. You want to keep wiggling it. Oh, I'm wiggling the whole board. You want to touch it with the soldering iron. I need to jack this up a little more somehow. It actually needs to be down that way and jacked up this way. That's better. So you can see on this one it's still it's still attached. I'll have to get my old man specs out again. And of course, I can't see where they're at, so I have to grab my second pair. I have two. There we go. So you're gonna work the solder away, and then you can always take a little bit of solder braid around that joint. What you're wanting to do is when you wiggle it, this one suddenly is nice and free all the way around. You just need to pick the one that does that does the best job. Make sure it's straight and it's free from the solder. And this other one's wiggling in the solder, but we don't care. Once one is fully free, we can heat the second one. Give it a little wiggle and slide it right out. So you're only looking to get one actually perfectly free. Clean this one out a little here. Whoa. Uh-oh. We had a catastrophe. Nope, we'll fix that later. So, try this one. And a little solder braid. Just try to suck up the last of that. Man, when you get it all out, you'll kind of know. It'll just be bam, kind of pops. Any layer of solder that's holding it so little. And you get to slide out. That one had a little bend down. It was making it tight. And these do look to have a little maybe spot of glue that they tap a little glue in, so we're having to kind of pop that free, but that's okay. There we go. Hopefully my fat head's not getting in the way, my ugly fat bald head. Just about got all that. We'll hit it with a tiny bit. Sometimes you can go in here and heat up around them, but sometimes it just flows a whole bunch more solder in the way. Heating the lead itself, and then wiggle it once it's molten in there, and keep wiggling, and then it'll end up free. That's what this one's done. Make sure it's good and straight. Make sure we got a wiggle. Getting our hand in underneath there to get a hold of the capacitor. just slides out. Like I said, having a big soldering iron makes a difference, or having a quality small one. But you can do it with the small ones. I've done it. It's just not as fun. You have to take time and steps. Don't overheat the board in one area. Just keep working that solder away. Wick it away. Some of you are going to want to comment, well, solder wick is not cheap. It's copper, and copper is expensive. Yes, you are right. But broken stuff on the boards, or tore out vias and stuff like that's worse than spending a little money on solder braid. And it actually lasts a long time. And like I showed with this repair over here, you can keep some of your scraps. If you had some of this solder braid that was partly soldered in, you nip it off and just leave a little bit to where you can punch your hole to do a repair like that. You can reuse the part that's soaked up some solder. Save yourself some money that way for some of your repairs. So that looks like that's free. Is it free? Soldering iron down so I don't burn myself on checking this. Yep, that looks good. So here we go to get this last one out, maybe. It just slides right out. So normally when you get them out, the holes are normally pretty good. Not always. We can always just test them. Hopefully these are all big enough. We may have to go back in and clean around them. We'll test it all to see. Looks like everything's through there. And you can see they did have a little bit of adhesive goop on the bottoms of these to hold them in place. So that's better than what I was thinking, because when I first seen this, I thought, man, those are awfully big capacitors not to have any goop on them. So we might put a little dab in there. It does, on this board, show you where the positives are on this side. And then, like I said, that tang is the negative. We're going to use some nice, these were Sacatronics. I've never heard of them. But that one's wobbling on the top real bad. That one's got a wobble. That one's pretty flat. And that one, no wobble. Notice the new ones, zero wobble. When you run your thing, the shrink wrap that's on these actually never contacts the center of the thing. So that's partly how you can tell. So that one's, if it's got a bulge, it's still underneath a little bit. This one, when you get up in the middle, now you got a wobble. This one, yep, that's got a wobble. And that's how I tell if they've been bulged. All these other capacitors should have clearance that you can see through when you go, and just usually any old straight edge there. So all these caps except for one may be really, really bad. Let's see, those three really bad, and that one, we're going to use my little tester on them just to see if they're way the heck out of tolerance or whatever. So let's get some E6000, and we're gonna put a little goop there. You'll actually find that you'll throw this away before you use it all up on amp repair anyway, just because it glues its lid closed so much that it takes so much work. You'll end up splitting the cap and wearing it out slow but sure, but it's not expensive. It's cheap at Walmart. So we're going to get a little bit. We'll put a little dab there and a little dab there. A little dab. Just a little dab will do you. And a little dab. I want it where the hole is. Throw that in the wastebasket. And then when I get done soldering this in, I'll probably put a dab on all the tops of the capacitors. And these have got a little wobble to them, so I'll probably put a dab here and a dab there. Just because I like to make it, lasting. Check the Only check the transformers. If they end up needing a goob, I'll goob that on there. I want the amp to last. Everybody wants their amp to last, and cars are full of vibration anyway. You add a big speaker box, you add more vibration with, you know, subs, and if you mount these suckers to the speaker box, then you're really doing it. The best boards have hold downs in the middle, like this one does, to keep the whole board from flexing. Excuse me, I'm gonna have to get a sip of water. Because if there's no support in the middle of the board and it's vibrating and the rest of these are clamped down, it'll break all the legs of the FETs. So if you get a board that doesn't have any center support, you can get some little foam wedges in the makeup aisle and glue them into the heatsink case the way you slide this in. I'll have to show that sometime, and give a little push up, little support to the bottom so it can't sit there and vibrate right in the middle and end up breaking all these legs. So we need to, got the negative marking on the capacitor. We know that this little tab is the negative, and so we're going to see if this will fit down in. That's pretty good. Got that one. And here we go down through here. Got that one. And we'll get this last one. Down there, get snapped into place. Flip this over. And now we got our legs. We can pull these apart a little. Now they had laid the others over, and I guess we can on this too. You can end up clipping it anyway, but we'll go on ahead and lay it down as best we can. Get out our soldering iron, and we get a little solder on the end, and we just want to heat the leg here. And notice I'm up on the leg a little bit until we get a little flow. And I'm just going to go ahead and flow that in on around there. Bam. Now, invariably, somebody's going to ask, could you put bigger capacitors in? Will it make my amp more powerful? No, it will not make your amp more powerful. If the amp design, if they had skimped on the capacitors to what was barely just needed to get the job done, and you put bigger ones in, you can, you can help the amp out. You can help give it a little bit. Might keep it from clipping quite so early, or something like that. But really, there is no such thing, very, very rarely, such thing as upgrading components in an amp to get more power out of it, unless the amp design already had that in mind and the manufacturer dialed it back for some reason, maybe for more sound quality, or that its design happened to be, somewhat supporting of that. The amp's really got to have support for that before it can do. And so somebody out there will say, oh, well, what about SoundStream, old Class A amps and stuff? Yes, those can be upgraded, especially because SoundStream designed the amp to be able to do more than what it was capable of and left lots of headroom and stuff in it. So there's guys that know what they're doing, like Jeremy Loftus, I'll name drop, as a guy who really knows some SoundStream stuff. And they know how to get that extra juice out. So, bam, we have got the caps all in there. They're not going to touch anything. All of mine are well below any surface that's going to touch anything. So we got 4 nice, shiny new. Ooh, got some junk fell off there. Caps in there. This thing should be ready to roll. We're going to want to hook up power, test all the waves, and then test all the output channels. But before we do that, when you test with these, you have to make sure the capacitor is discharged. So you need to put a piece of metal in between the legs. Make sure it's totally discharged. Otherwise you can run these little cheapo testers. But these little testers are handy. And so now that we're discharged, you just hook up a leg to each and hit test. And these should be 3300 microfarad, 35 volt caps. And we'll see what the ESR comes up on these. So 3366 with a 0.79 ESR, that's actually good. And that is one that has just got the slightest hint of a bow. Nice low ESR, 33.7. So technically, it may look like none of these were actually toast. They have just been overheated enough that they've started to swell, and they may be either that or it's set. And this isn't that old of an amp. 3300, nice low ESR. It's not too bad. Oh, see, that ESR jumped up quite a bit. Is this the worst one of the ones that are bulged? These two were the worst with that bulge in the middle. So, you know, it jumped up a little bit to 1.2 ohm. Not too bad. They probably would have survived, you know, all things considered. They may have bulged when this popped, and there may have been a direct short somehow and put these through a bit of a hurt or something. But man, once you see that cap bulge just a little bit, if you've ever done any repairs on anything electronic or read about the bad capacitors, and everybody says, oh, the amp works fine, it just needs new caps. Well, this tells you it needs new caps. These were going, these have taken some damage. They're going in the trash. Oh, knocking stuff off here. I just don't trust them. When you see that bulge, that means something's went wrong, and the internal pressures have built up, and we just don't want that. So what we need to do is flip this puppy over very carefully, and this should be ground. This should be the remote. If you're wondering, I got the front faceplate of the amp over here where I can see it, so I can see what the hookups are here. And see what I mean. And if that's in there, the subwoofer output, positive up here and negative down there. I'm going to start with the sub because I'm assuming, you know, we haven't tested it since because it had a dead power supply, so you can't really test it at all. I'm going to assume that they probably blew this thing by running the sub too hard, too low of impedance or something. They may have been running all the channels, but wired their sub. Got a little greedy, wired their subs down low and low impedance. And it was, you know, the power supply FETs hopefully were enough to handle it, or I mean the output FETs, but the power supply could not handle all that going out. So we make sure our stuff's out of the way here. We're going to need to make sure we have this, and then we're going to want to look at the other side of the amp here, this side. That's in place. And we're going to want to, the subwoofer input is going to be these two. That's front and that's rear. That's good. So the mode, we're going to switch all the modes to low pass with a frequency selection. Well, because we're going to test this all on a sub, and then I'll get some other speakers to test this other one on. But my main test set up as a sub. We'll set the low pass for about 100 hertz. The subwoofer was set way down at 30, so we're set at about 100. This phase, we're going to zero out. We want all the boosts off. That's off. That's off. That's off. We'll turn the gain to a third, or maybe a quarter on all of them. And that should set us up. Now, I don't want any of this touching and shorting out, because normally it's bolted in. So we're going to put a nice little piece of plastic there to keep all that from touching. All right. Bring our RCAs in over here. Got the sub hooked up. Okay. Very careful. We're not plugged in correctly here. Make sure you get all the pins in the right holes. That could have been catastrophic. All right. Set my multimeter to voltage. Make sure we got good 12.5 volts feeding this puppy. See if I can get this on the camera here. There we go. 12.5 volts. That's what my power supply puts out. First thing we're going to do is, before we put any music to it, we're just going to give it a blip. Here she comes on. Oh. Alright. There we go. Okay. So I've got the meter set. There is the drive, and here's the back of the FET, and there is the output. That is the output on all the FETs. See how nice and, oh, that's not FET, pretty that wave is on all the FETs. Now we're going to let off power. We're going to check. Nothing was getting hot. Nothing hot. Okay. Now we're going to power up our signal source and make sure it's turned way down. might be on a commercial, you never know. I'm going to make sure the volume's way down. And we've got a speaker hooked up, and we've got frequency coming in. Not getting anything yet. We are turned up in the volume, but we don't seem to be getting anything out. So something else may have caused, when something in over here died, it may have caused this to die. Now this input, I don't think, and we're going to turn off the power here for a second so we can unplug this. Oh, look, no, that does not look like that provides any ground signal. Okay, we're going to switch. This should be front. I was looking to see if these pillars that hold this up on the amp, if they happen to provide ground source for this or something. They do not appear to. Oh, except we need power back off. We are going to try the front. So this is how you'd go about end up testing for your output section. Now that this thing's not going into protect, we still don't have a sub out. And so the front is these top ones, and we got positive, negative, positive, negative. Okay. Go ahead and back these screws off so we can go through and check all the fronts. And then we'll move the RCAs to check the rears and see what we got. Because what we're doing here, this is the next step in the process of fixing an amp. Is once you got no apparent shorts in the outputs, it doesn't go into protect, it's not blowing any fuses. Oh, sorry, that's positive here. Then you got to go through and put a test to see if you're actually getting any output. This can be a time-consuming part of it. Sure. So let's power it back up. Fire up my head unit. We'll go ahead and apply a little power to the amp. Alright, that was successfully playing through the front. Now maybe if I over here on my I can show you with my little cam. I've got my inline fuse here. I'm going to pull that apart so it doesn't kill my head unit ready to play, but it's on pause. But that killed the amp. And I'm going to drag this thing over and very, very carefully swap the speaker wires and not touch anything to ground it out or anything. Well, I don't know how many amps I've worked on. You could tell somebody touched the speaker wires together or grounded them. So, okay. Let's plug the power back in. That's why I like that little fuse holder. I can just plug and unplug. I'm going to let the amp come back on. And pause. And it is playing. So we're going to pause that again. Unplug the power. And we're going to move on up to the rear outputs. What kind of time are we at? We're dang near already 40 minutes. Oh. So I'm trying to hurry, get all these tests in. Oh, that was not good. Power supply said something didn't seem cool. Oh, I think I know why. No, negative. We're good. Let's try powering back up here. Make sure we're at 20 volt. Or 12, sorry, not 20 volt. 12.5 volt. At the source. My power supply is a Dell server power supply that's been modified so it can be put out for my use. But one of the neat features of it is if it gets a real quick spike in current, it'll actually shut itself off. Alright. Came on. Oh, I did not. Where? Okay. Real careful. Move the audio inputs to the rear. And there we go. We got music coming out there. I'm going to disconnect power. Feel and make sure we're running it real short time, really quick, because we do not have this amp in the heat sink, and so those FETs can overheat in a heartbeat and burn themselves up. So you have to be real careful and monitor the heat that's on them. And so far we haven't played it long enough to get anything warm, which is exactly what we want, real low volume. We'll plug back into power. We'll go ahead and power it up here. Yep, you can catch it right there in the corner. Excellent. Alright, so the only thing remaining is the sub channel. And one thing I'm curious about, so the sub says negatives on the bottom. Put back into there. And put this one into there. Somewhere. It says subwoofer in. So we should be right here. Powered back up. The light comes on. We should be playing, and we're not. So sub channel is still not good. We're going to kill all the power. The subwoofer channel is still not working, but we have a functioning power supply. We have functioning front and rear, all 4 channels. Now I'll just need to do one more last video where we trace this back. None of these are shorted, so that means we might have a little driver problem, something like that. I'll probably set this off to the side because I got one other thing I got to do more. Sometimes troubleshooting all these little drivers can be a pain, and I'll want to look them over really well to see the output. But we're up to functioning amp. 4 channels are working, sub does not. We will figure out this sub channel and get it repaired, but there'll probably be a delay. I was hoping that all that worked when I picked this amp because I knew it had blown power supply. I was hoping to show a power supply repair only, but we'll leave it at this for the time being. We'll come back and I'll do one after we've got a chance to inspect all this. I'll figure out which side is and get a little checking and probing. And I haven't really looked all this over real well. It may be something glaringly obvious, and we'll give it a double check. But we will get back to it, get that subwoofer channel working, and then this sucker can go back in its case. Hope you learned something. Hope that looked good. Those square waves and stuff and this capacitor change, like I said, I'm going to add a little goop to the board here and to the board on this one, and then probably goop a little between on these just so they can't shake and rattle. And then I'll go over this another day. I've got a couple others I want to do. Been promising everybody some Rockfords and JLs, and I've got a couple other things to look through to try to find exactly the kind of problems I want to show as we build steps. This output section step is kind of later in what I want to do in the video series of this stuff, because I want to show simpler things, but I got a funny feeling that since all these check okay, it's going to be in here in the drive circuit of this thing. It could very well be in here. I'll have to test if it's somewhere in the input circuitry and maybe we're just not getting signal. So it could be that. But like I said, I'll have to look around, and don't want to overwhelm everybody. We want to do this steps at a time and get everybody familiar so they can take their time and look their own amp over and maybe find an easy problem that they can fix. And if they got an old junker amp that they can actually tear apart and not have to worry about it if it's not their really nice, expensive, good amp, find an old junker to work on and do a little learning and a little testing and have a little fun with it and recycle and reduce and reuse. Save your money and stop sending stuff to the landfill. So if you like it, likes are appreciated. Really want some comments. Love the interaction. Got a few comments, and that's the most exciting thing about this whole thing. If you like the content, give it a subscribe. All the subscribes help, because then you know when I've thrown another one of these crazy videos up. And I thank you very much, and thanks for watching.